All right. So Rome's on the boat.
Oh yeah, dude. I'm sailing.
Rome's chilling out on the boat. Who's on the cliff? Thane's on the cliff. Okay, so Thane's on the cliff. Thane's on the cliff, and Thane sees Rome on the boat. And he's like, you know what? I bet I could drop a rock on Rome. So he gets a rock, and he gets a rock and he drops it. And what we're going to look at is the displacement, the velocity, and the acceleration of that ball as it falls off the cliff.
Ball or rock?
Well, rock, definitely a rock. Because a ball would be, balls are designed to kind of catch the air, so we want to ignore as much air resistance as we want, as we possibly can possibly. It could be a bowling ball, but you don't want to drop a bowling ball in the ocean because, good luck with that. So we're just going to assume it's a rock. So the three things we want to look at are displacement. We want to look at velocity. I wish I had a fourth pen, but I don't. And acceleration. And unfortunately, time is also going to have to be black because I don't have a fourth pen. So those are the things we're going to be looking at. Now, he's not going to throw it. He's just going to take the rock and he's just going to drop it. Okay? So at time equals 0 seconds, how far has the rock fallen? At the moment he releases the rock, how far has the rock fallen?
0.
It's fallen 0 meters. Okay? So at 0 seconds, it's fallen 0 meters. And at the moment he releases it, how fast is it going?
No way.
Yeah, it has no speed. It has 0 meters per second. Okay? So far, so good, right?
Yes, very good.
Okay, now we have a series of formulas. We went over the formulas yesterday. Those really cool formulas were, this one, and this one, and then delta V equals AT, which is kind of like that one. Okay, and then D naught T plus 1/2 AT squared. Okay. So what is the acceleration at time equals 0? Be careful. What is the acceleration due to gravity at time equals 0?
It's still 9.8 meters per second.
Yeah, exactly. It's still going to be 10. It's still going to be 10. Because if it wasn't 10, if it was 0, then what would the ball do when he dropped it? It would just stay there, right? So the acceleration is still going to be negative 10 meters per second squared. So far, so good? All right. So that's time equals 0. It's a little bit distraction. There we go. All right. You can see the other formulas. Doop-a-doop-a-doop-a-doop. Hey, look, I can pan and scroll and stuff. All right, so that's time equals 0. Give me a thumbs up if these numbers make sense to you. Okay, looks like most of you are on board. Now, at time equals 1 second, things change a little bit. So I'm going to put the ball right here. This is t equals 0, and this is t equals 1 second. So at 0 seconds, now at 1 second, we got D, we got V, and we got A and T. Okay, so there's A and there's T. So now we're talking about time equals 1 second. The easiest one here is going to be the acceleration. What's the acceleration 1 second after he drops it?
-10.
Still negative 10 meters per second. Okay. As long as that ball doesn't approach the center of the Earth, it's going to be negative 10 meters per second. Now, because everything down and right is going to be negative, and everything up and left is going to be positive, just by convention.
So wouldn't it be down and
He
left
was
is
saying
negative?
his left, all right.
Oh, yeah, his
Everything down and everything
Okay.
down and left is negative. Everything up and right is going to be positive. So, like we're slapping a Cartesian plane on our two-dimensional motion or our one-dimensional motion.
Okay.
Thank you. Okay. Now, velocity. It's had 1 second to speed up. What is the new velocity of the rock? Remember, velocity is how acceleration changes. Using this formula, delta V equals AT, it's had a second to speed up. What is the new velocity? Negative 10 meters per second, exactly. So the new velocity is negative 10 meters per second. In other words, the velocity is given to us by AT. It's had 1 second to fall under the influence of gravity, which is negative 10. So velocity is negative 10 times 1, and negative 10 times 1 is usually negative 10. Scott.
Now, if you were to say just speed, it would be negative 10.
Correct. Yeah, exactly. If we just said what is the speed, then we could throw out the negative and just say it's 10 meters per second.
That's speed.
Yeah, because speed doesn't have a direction. Very good point. All right. Did I say velocity or speed?
No, you said velocity.
I said speed? Okay, so let's pretend it's velocity. Let's try, let's do it right. So does this make sense? Why it's negative 10? Okay, now listen carefully. The ball was just dropped. We know how far something will go if it is dropped using the free fall formula. The free fall formula is d equals 1/2 at squared. Free fall. So, how far has it fallen after 1 second? Yeah, negative 5 meters, exactly. It's fallen negative 5 meters. D, that's what we're looking for. 1/2, okay. Negative 10, all right, that's negative 5. 1 squared is 1. Negative 5 times 1 is usually negative 5. So it's fallen negative 5 meters. So that's how far this thing's gone. So that's 5 meters. After 1 second. Cool so far? Okay, questions? Put your hand up and wave it around if you have a question. If you're comfortable doing 2 seconds, give me a thumbs up. Question?
The distance formula is the d equals VO plus 1/2.
V naught.
It's okay. Yes. VO, V naught, VI, whatever. Yes, what's 1/8 VT squared? Exactly. So that's what we're using. Why did I not include this term? Exactly, because it's freely falling. It hasn't been thrown, it's just freely falling. Okay, so if it was thrown, we would have to add a term here. But since it's freely falling, we can just ignore that.
So then it just be d equals 1/2 at squared.
Yes. Yep. That's the free fall formula. Something is freely falling, d equals 1/2 at squared. If something is thrown up or down, then you have to add that term. And if there's air resistance, then on air resistance. But anyway, we'll talk about that later. Cool so far? All right. What about 2 seconds? So d equals 2 seconds. We got t, we got a, we got v, and we got d. Okay, so at time equals 2 seconds, what's the acceleration due to gravity? Still negative 10, yeah. The acceleration due to gravity is still negative 10 meters per second squared. But it's been falling for so long. That's okay. If we're ignoring air resistance, it's going to continue falling for negative 10 meters per second squared forever, as long as we ignore air resistance. If we don't ignore air resistance, we encounter something called terminal velocity. But we'll talk about that in October.
Wait, isn't like terminal velocity, like it can only hit that speed maximum? Okay.
Yeah, that's what happens when you have upward air resistance. But without upward air resistance, poof, no terminal velocity.
Ooh, right.
Back in space. You just keep going faster and faster and faster and faster and faster and faster and faster.
Sounds like a plot.
Okay, velocity, like these pants. Velocity. In 2 seconds, it's had 2 seconds to, speed up.
I just have a weird question. So if
Go for it.
different objects will have different terminal velocities, right?
Yes, they will. Yeah. The air resistance is a function of how big a hole you're punching in the air and what kind of texture you have. And it varies with the square of velocity, which is why we don't usually use it because it requires calculus. Calculus is what we use when one variable, when the x is changing, causing the y to change also. So when there's a relationship like that. So air resistance varies with the square of velocity, so we don't use it until you go to college physics. Then we can do calculus.
That's crazy.
Totally bonkers, man. All right, so velocity. It's had 2 seconds to fall. So at what is its velocity after 2 seconds? Negative 20 meters per second. So good. It's going negative 20 meters per second after 2 seconds. And how far has it fallen? Yeah, so you've already done the math. 1/2, okay, I can handle that. -10, that's -5. 2 squared is normally 4. 4 times -5 is -20 meters. So it's fallen after 2 seconds, it's fallen 20 meters.
So it jumps from -5 meters to -20 meters. Oh.
Why do you think it covers much more speed or much more distance after that second interval?
Because its initial velocity from the second interval is -10 instead of 0, so it's already going at a higher speed.
Right, exactly. It's got a higher speed from here to here, so it's covering more distance. So with what we just have, I bet some of you can figure out the important statistics for t equals 3 seconds. So give it a shot. Good shot. See, what is the distance, or displacement, velocity, acceleration, and time at t equals 3 seconds?
40.
Go ahead and just plug those numbers in, and we'll see how we're doing.
Distance be 40.
Sorry, did I say 4 seconds?
20.
I meant 3 seconds. Okay, 3 seconds.
20 times 4 is 80. Right. Okay, 2 seconds.
I think those are called booster tails. Just going off the back of a jet ski. Okay. Anyone need more time? Cool. All right. So velocity. It's fallen for 3 seconds. How fast is it going after 3 seconds? -30 meters per second. And how far has it fallen after 2 seconds?
-45.
-45 meters.
Oh, dang.
Excellent. 45 meters. Okay. Cool?
Yeah.
Then it goes sploosh. And it turns out it goes sploosh. So this is the sploosh. Sploosh. It goes sploosh at a time of 3.5 seconds. How high is the cliff? It goes sploosh at 3.5 seconds. What is, we're going to say, I'm going to call this D max. D max. Basically, how high is the cliff? Or the ball hit the water? Or the rock hit the water?
Not very fast. It is.
3.5 second sploosh. Using what you know, how high is that cliff?
It's going -35 meters.
Answer a question. Hold on a second.
Yeah, hold on, it's not there yet.
It's -5. Which would equal
It's like, you really did that.
I see some people banging on calculators. I see people talking about whatever you're talking about.
okay.
If you have an answer, give me a thumbs up. About 2/3 of you. Take 10 more seconds to bang on your calculator for a little bit longer. Okay. If you got an answer that is more negative, if you will, than negative 45, raise your hand. Good. More negative than negative 55? 65? Okay, what'd you get?
Negative 61.25
Negative 61 meters?
meters.
0.25
meters.
Okay, so negative 61 meters?
Yeah.
All right, so how'd you get that? How'd you go about finding that?
So yeah, we have the acceleration and the time, and then we just use the free fall formula.
You did that, right? So 1/2 times negative 10 times 3.5 squared?
Yeah.
Anyone have trouble matching this to this to this? If you're comfortable seeing where this came from this, give me a thumbs up.